Hi, I'm Zoe from STEM for Others. In this lesson, we are going to talk about physical quantities. In physics, we like to measure things. For example, we use a clock or a stopwatch to measure time, a thermometer to measure temperature, a scale to measure weight, and a ruler to measure length. In physics, things that are measurable are called quantities, like time, temperature, weight, and length. And we have devices to measure each physical quantity that we are interested in. We categorize all physical quantities into two main types. The first one is called a scalar quantity. Let's say I took a 2-hour nap today. The 2 hours is a scalar quantity because it can be measured by a stopwatch. A scalar quantity has two components. 1. The numeric value, and 2. The unit. The numeric value and the unit combined are referred to as the magnitude. Please note that the unit is very important. We can have the same scalar quantity represented in a completely different form using a different unit. For example, 2 hours can also be represented as 120 minutes. So, from now on, when we present a scalar quantity, be sure to also include the unit. Besides scalar quantities, we have a second type called vector quantities. For example, I want to describe the location of my house. I can say, my house is located 1 mile to the east of my school. 1 mile to the east is also a physical quantity because it can be measured. But this quantity has a little more information. Like any scalar quantity, it has the magnitude, which consists of 1. The numeric value, and 2. The unit. In addition, a vector quantity also includes a direction component, specifying where the magnitude points. This additional information is important because it avoids confusion with another house also located 1 mile from the school, but in a different direction. The direction component of a vector quantity ensures that we precisely describe not just how much, but also where the quantity is oriented in space. To summarize, physical quantities can be classified as scalars and vectors. Scalar quantities include time, temperature, energy, etc. These quantities remain the same regardless of the direction from which they are measured. For example, 2 hours is still 2 hours regardless if it's measured from the east or from the west. Scalars have magnitude, numeric value, and unit, but no direction. Some examples of vector quantities are force and electric charge. They are considered different quantities if either the magnitude or the direction is different. For instance, the effect of a force pushing from the right is different from pushing from the left, even if the magnitude of the force is the same. This difference in direction affects the outcome of the force, illustrating the vector nature of physical quantities. In the upcoming lessons, we will delve deeper into physical quantities related to motion. We will explore how scalar and vector quantities play crucial roles in understanding and describing various aspects of motion.